Hello students, welcome back to Turito's live classes. How have you been? I hope you are having great time. Students, we have started the chapter called as what is matter around us pure, correct? And we are into the next session of this chapter. So before going ahead, it's time to revise whatever we have covered in the last session, correct? So let's quickly go through the topics which we have covered. So we have talked about solubility, factors affecting to solubility, temperature, correct? And then we moved in the next class, which was the last, where we talked about what is true solution. Okay, what are different properties of true solution. Then we talked about the concentration of solution. Okay, and then we solved some questions which are based on the true solutions. Okay, on the concentration of solution, correct? Then we move towards the suspension, that is the next type of solution which we have, which is nothing but suspension, correct? So we know that what are the properties of true solution? True solution is also nothing but it's kind of homogeneous mixture. So I have given you one example, salt solution, or next example was like sugar solution. So here sugar or salt particles are completely dissolved in water to give you one single solution. Okay, so there are no different boundaries between these two substances, correct? And that's why we said it's nothing but a true solution. Of course, it is not possible by us to observe the particles through our naked eyes, because the size of the particles, okay, so it's very small. So how small is it? It is, the size of the particle is smaller than 1 nanometer. Okay, so 1 nanometer, which is nothing but 10 raised to minus 9 meter. So they are very tiny, and that's why when they dissolve in water, we don't see them through our naked eyes. Also, it is not possible to observe them under microscope. Okay, so there were some properties which we have seen, like the true solution is not going to scatter the light. Okay, when we are going to pass the beam of light on true solution, what happens there? We don't see the scattering of light. Whereas we are going to understand the new type of solution in today's class, which is nothing but colloidal solution. There we observe like those particles which are present in the colloidal solution, they are going to scatter the beam of light. So students, we have given the name of this scattering of light, that is nothing but Tyndall effect, right? Tyndall effect we have talked about. So because of small size, particles do not scatter beam of light passing through solution. Okay, therefore the path of the light is not visible. That is the next property. Let's move ahead and talk about, like, if I want to separate salt solution or if I want to separate the sugar solution, I cannot do that separation with the help of technique known as what? Filtration, because the particle size is very small along with the solvent. Or I can say when solute is going to dissolve in solvent, both solute and solvent togetherly as a solution going to pass through the filter. Okay, and whatever we are collecting, it's as it is, like its true solution is getting collected again, because with the help of filter paper we cannot separate the true solution. Okay, that was the property of true solution. Now let's move ahead. Then we have observed that when a solution is allowed to stand undisturbed, the particles of the solution settle. This shows that solution is what? Stable, correct? Now the next one property is that the solution is always transparent in nature, it may be colorless. Okay, so students, these are some property which we have covered, correct? Then let's move ahead. We have talked about dilute solution and concentrated solution. So dilute solution has more numbers of solute. Okay, so amount of solute is, the dilute solution has less number of solute. Okay, concentration of solute is less in terms of dilute solution. But when we talk about what? Concentrated solution, here we observe concentration of solute is what? More, correct? So we have seen some like examples also, such as what? if I am giving some example, such as like if I am adding a little bit of salt in water, a little bit of salt, but solvent is in extra quantity, that is what, let's suppose water here, this is a dilute solution because we have added whatever the amount of solute we have added in the solvent is quite lesser. Okay. Now moving ahead, let's try to understand concentration or the concentrated solution. Here the amount of salt is huge. Okay, we have added a lot of salt, and that's why we say it's nothing but a concentrated solution. All right. So always remember, a solution with less solute concentration is what? Diluted solution, or a solution with high solute concentration is your concentrated solution. All right. Now let's move ahead. We have seen this combination of solutions such as solid and liquids, where solid is your solute and liquid is your solvent. Now students, we talked about the concentration. Okay, so how many solute particles are there in the solvent? Okay, in what kind of solution? Solid and liquid types of solution. We are having two methods to calculate it. Okay, first was like the first term was mass by mass percentage. What it was? Mass by mass percentage. And how do we calculate the concentration for this? Is like, this is the chemical formula. See, W by W percentage. We are calculating this concentration in terms of percentage. All right. So we are having mass of solute divided by mass of solution into 100. Correct. And based on this formula, we have solved one numerical, right? Let's move ahead. Then we talked about the next term, mass by volume. So this is again a calculation of concentration in terms of percentage, but how? Mass by volume. For this we need mass of solute divided by volume of the solution, and we are going to multiply with 100. Correct. Now yes, here also we talked about like how am I supposed to create 10% by volume solution. How are we going to create 10% by volume solution? Here we need, suppose if it is a salt solution, you are going to take what? 10 gram of salt, and you are going to dissolve this in 90 ml of water, is going to give you 10% by volume solution of common salt. I hope you all are able to recall whatever we have covered, because this is not very new concept which we are starting today. We are going to see what are colloidal solutions, but before that I thought let's revise whatever we have covered. All right. So let's move ahead. We are having next concentration term, which is nothing but this is for the combination liquid and liquid. Okay, here we are having solute which is liquid and it's getting dissolved in solvent, and then concentration term which we have is what? Volume by volume percentage. Okay, so how do we calculate that? Volume of solute divided by volume of solution into 100. Correct. So students, try to understand, this is very important. Okay, so make a special note for this type of numericals or formulas. Correct. So based on this we have calculated some or we have solved some numericals. Then moving ahead, we talked about the next type of solution, which was what? Suspension. So how we got the word suspension? Students, it is nothing but a solute particle is going to get dissolved in what? Solvent. But here the particle which we have added, or the solute particles, are going to be suspended in the solvent. They are going to be there in the solvent. When you are going to you are going to stand that solution for some time, you are going to observe that the suspended particles now they are settled down at the bottom of the container. Okay, the particles earlier were suspended, and that's why the word is what? Suspension. Okay. So it is a heterogeneous system in which the solute particles do not dissolve. Yes, earlier they were suspended, and when we stand the solution for some time, it is going to, or the particles are going to, they are going to settle at the bottom of the container. So yes, definitely they are not going to dissolve, and that's why we say it's heterogeneous system. I hope you all are able to get it. Correct. So particles do not dissolve but remain suspended throughout the bulk. Okay. The particles of suspension are visible to naked eyes. Okay. In true solution, we saw that I am not able to see the salt particles in the salt solution. We were not able to see the sugar particles in the sugar solution. So, here we have different types of suspension, and here it has the property that the particles of suspension are visible to our naked eyes. Okay, because their size is very bigger than true solution. It's greater than 10 raised to minus 6 meter. So, it's huge in size basically, and that's why like we are able to see the particles in the solution. Alright, here we are talking about suspension, students. Okay, so do not get confused. So, here is the example such as what? Chalk water, then we are having muddy water, then we are having sand particles in water. So, we have seen all of these examples in our daily life, right? So, we don't see that chalk powder is getting dissolved completely in water, or mud is getting dissolved in water. What do we observe? We observe earlier, as soon as you are going to stir the solution, okay, the particles are going to get what? Suspended, correct? After some time, what do we see? Okay, this is what is the water, but the particles are settled down at the bottom of the container. Alright, so here is the diagram of suspension. Okay, so these are the particles which we can observe through our naked eyes. Alright, so suspension is heterogeneous mixture. Okay, so this is a suspension, and once they are going to get down, or they are going to settle down, it is going to give you new word which I talked about, precipitation. Okay, if they are going to be in the bulk, they are going to suspend there, they are going to be there, that is what? Suspension. But when they are going to come down, settle down at the bottom, we say it's suspension. Alright, so here we have three categories. Okay, basically it's A, B and C. As of now we are done with A, and currently we are talking about what? Suspension. So, what is the particle size? It is what? It's greater than 10 raised to minus 5 centimeter, correct? So, that's why the particles are quite visible to our eyes. Here they are less than 10 raised to minus 7 centimeter, and that's why they are very tiny, they are very minute, so we are not able to see through our naked eyes, correct? And the part B is we are going to start in today's class. So, let me get finished with the suspension first. Okay, so again, the particles of suspension scatter a beam of light passing through it and make its path visible. When the particles settle down, the suspension breaks and it does not scatter light anymore. Okay, the particles or the suspended particles can show the beam of light, okay, because scattering of light is happening in case of suspension. But if the same particles, if they are going to settle down at the bottom of the container, we see that of course they are not going to scatter the beam of the light. Okay, so here we talked about the Tyndall effect, students. Okay, these are the air particles, they are going to reflect the light energy, and that's why the path of that light is what? Quite visible, correct? So that is what Tyndall effect. And here we have compared between like a solution, colloid and what? Suspension. Then we talked about what? A solute particle settle down when a suspension is left undisturbed, that is a suspension is unstable. Okay, so that's where I have given you one example, students, such as what? We have taken lime water, calcium hydroxide, when it reacts with what? Carbon dioxide, gives you precipitation of what? Calcium carbonate, correct? So that was the example which I put there, and then we talked about like how these particles are getting precipitated. So real life example such as what? Muddy water. So the mud particles are going to get settled down at the bottom, correct? Giving you precipitation. Now next is what? With the help of filtration method, we can separate the components of solution. Alright, and these are some real life examples where we observe suspensions. Okay. So paints, then we are having milk of magnesia, bleaching powder, then we are having what? Calcium carbonate. So these are few examples which we are using in our daily life as what? Suspensions. Alright, that was all about, student, the topic which we have covered so far. In today's class, we are going to learn the third category of solution, which is nothing but what? Colloid. Okay, so what do you mean by colloid? Or definitely here we are emphasizing on the size of the particle. So the particles of true solution are smaller than 1 nanometer, therefore they are not visible through naked eyes or through a microscope. Okay, all right. The solid particles of suspension are quite large, having diameters greater than 100 millimeter and hence are clearly visible to the naked eyes. Here, students, I told you we are having two extreme solutions. Okay, here we talked about what? True solution. Correct. We have three types of solution. We talked about true solutions, and then opposite to that we have what? Suspensions. What do we have? Suspension. So the particle size is very tiny or it's very small in case of true solution, and it's very large comparatively in suspensions. But in between we have a different type of solution, which is nothing but what? Colloids. Okay, that is what we are going to study about. In between these two categories of substances, there is a third category of substances which dissolve in water or any other liquid to form a mixture in which the size or diameter of the particles is what? In between 1 to 100 nanometer. Okay, the size of that particular colloid particles lies in between, the range is what? 1 to 100 nanometer lies in between those and a true solution and suspension. Exactly. So, true solution and suspension, in between what do we have? We have colloidal solutions. Okay, the size of the particle lies in between 1 to 100 nanometer, correct? Such mixtures are called as what? Colloidal solutions. So that's how we have three types of solutions, students. True solution, then we are having colloidal solution, and we are having suspensions, correct? So the solution in which the size of the solute particle is bigger than true solution but smaller than that of what? Suspension. Okay, the particle size of the colloidal solutions is what? It's bigger than true solution. Okay, it's in between true solution and suspension. That's how we can say the size of the particle which colloids has is what? It's greater than true solution, but it is like smaller than suspension. So that's why we say it's in between. So try to understand. We are having true solution, students, then we are having colloids, and next to that we are having what? Suspension. Okay, suspension. So it becomes very obvious that the size of these particles lies in between true true solution and suspension. Okay, it appears as homogeneous but it is heterogeneous. Okay, so I have given some examples such as what? Clouds. These are nothing but clouds are examples of what? Colloidal solution. Then we are having milk. Okay, even milk is one of the examples of what? Colloids. So to our eyes, what do we feel by looking at these examples? We say that no, they are looking completely homogeneous, but students, they are colloids. Okay, if we'll see the nature of these substances or matter is what? Colloid. The particle size of the substances is like it lies in between what? 1 to 100 nanometer. Okay, that's why we say these are colloids, correct? So here are some examples: starch solution, milk, ink, blood, soap solution. See, these are like, though they appear, the examples which I have given, be it blood, ink, or milk or any starch solution, actually I understand they are like homogeneous solution. Okay, to our eyes they appear as what? Homogeneous solution, but their particle size is in the range of the 1 to 100 nanometer, and that's why we say they are what? Colloidal solution. Okay, you can make note of the here, note down the particle size, and next to that note down the some examples of what? Colloidal solution quickly. Okay. Okay, so it's a heterogeneous type of mixtures. Particles cannot be seen with naked eye. Okay, so try to understand, though they like in appearance they are like homogeneous mixture, but in actual they are heterogeneous mixture, and the particles cannot be seen with naked eyes. So students, once again let's compare among the sizes of these three different solutions, such as we are having true solution, we are having colloidal solution, and third we are having suspensions. Just have a look at these diagrams carefully. Okay, here what do I observe? That the particles of true solution are very tiny, or they are very small. Correct? How small? Try to remember, you are supposed to remember these particle sizes, because based on this particle size we have three different categories: colloidal solution, true solution, and suspension. Okay, so let's talk about the true solution. The particle size is less than what? 10 raised to minus 7 centimeter. Okay, that it is so small. Okay, now we are having next is what? Colloidal. So it is in between 10 raised to minus 7 centimeter to 10 raised to minus 5 centimeter. It is in between. Okay, and next to that we are having suspension. So particle size is greater, of course it's greater than what? 10 raised to minus 5 centimeter. It's greater than 10 raised to minus 5 centimeter. Okay, so quickly make a note of this, all of you. It's A, it's B and C. We have earlier we have completed A, then C, and now we are dealing with the B part, that is nothing but what? Colloidal solution. All right. I am again and again emphasizing on this part, like this is very important. So by heart these sizes. Okay, do not get confused among the sizes and the type of solutions, students. Done? So, true solution less than 10 raised to minus 7 centimeter, colloidal in between 10 raised to minus 7 centimeter and 10 raised to minus 5 centimeter, and suspensions greater than 10 raised to minus 5 centimeter. All right. Okay, let's move ahead. So here again we are going to see, these are some common properties which we have studied in case of a true solution. We have studied the same concepts in suspension, and that's why it becomes necessary to understand the same properties. Okay, how colloid solution is going to behave when we talk about what? Tyndall effect. So students, definitely what happens that the particles which are present in the colloidal solution, they are going to reflect the light energy. Okay, and that's why it is going to make the path of light visible. Okay, the path of the light is going to get visible because of the size of the colloidal solution. Okay, so this path of light is not visible in case of what? True solution, because the size of the particles is very small. And that's why we are going to observe, yes, colloidal solutions are going to scatter the light, and suspensions are also going to what? Scatter the beam of the light. So here scattering of light by colloidal particles is known as what? Tyndall effect. It is again the next concept which is equally important. Okay, scattering of light by colloidal particles is known as Tyndall effect. So here we have given again the same thing, sunlight passing through the canopy of the dense forest. Students, I have just kept this image so that you can relate to the concept, like what do you mean by Tyndall effect. We know that we are surrounded by air molecules, but you must have seen in the dense forest or even at your home sometime, like the canopy which is there in the forest. We see that whenever the beam is getting passed at some area, okay, we see that like we observe that the air molecules are quite visible, or they are clearly visible than the other area. Okay, because the particles have tendency to reflect the light. If the particle has considerable size, definitely we are going to see the particle and also the beam of light, which happens in colloidal solution and suspensions, and it is not being observed in what? True solution, because of the size of this true solution, which is very, very, very small. All right. Quickly make a note of this, students. Again, you have a trick. You can directly just draw this diagram and remember and comment on this phenomena. Okay, with respect to solution, colloid and what? Suspension. It is that easy. It is that simple. Just now I told you about, like, you can make the same chart and you can talk about, you can comment about the sizes of the particles. Okay, likewise, this is the trick. Okay, I always encourage students to make a memory chart or any memory map. That means you just have to cut short your whole sentences or big passages into what? Micro notes. Okay. Of course, with understanding. Okay, it's not just you need to mug up each and every concept. No. Let's move ahead. So let's try to understand some properties of what? Colloid solutions. So students cannot be separated by filtration. Okay, so the size of the particle, particle size of colloid is like if it is considerable, but it is not that huge, like you can separate the particles with the help of filtration. Okay, they are not big enough so that they can get filtered by the filter paper. So what is the method to filter this solution, which is nothing but what? Centrifugation. This is the method which works on the centrifugal force. What do? We apply the centrifugal force on the outer side of the body and the rotation is going to happen continuously. Okay, here is the machine. This is what is a centrifuge machine. In this we are having compartments. Okay, so here we can take a test tube and we can pour the sample. Okay, let's suppose any colloidal sample which we want to get separated. We can pour the sample and we can keep these test tubes in the machine, and centrifugal force is going to do its job when we are going to allow this rotation at high speed. Okay, the way we wash our clothes in the machine, students, like that the same phenomena is being observed here. Okay, which we are going to cover in the centrifugation. Okay, that is also separation methods which we are going to talk in detail soon, but I am giving you an idea. When it is going to get rotated at very high speed, what happens? There is a separation. There is separation between the lighter components and heavier components which are present in the sample, or it is present in the colloidal solution. Okay, because of that centrifugal force, students, separation happens. Here I have shown you, this is a sample. Okay, this is nothing but your colloidal solutions. These are the particles. Some are heavier, some are lighter particles. All right, when this rotation happens, okay, this is the rotational axis. So along along with this, what is going to happen? Rotation is going to happen. The test tube is going to get rotated very fastly. Okay, and when it happens, after some time we observe that the lighter, these are the lighter particles. I am going to write it here. Lighter particles are getting separated from the heavier particles. These are heavier particles. Okay, so lighter particles are going to get separated, and at the bottom of the test tube we are going to separate, we are going to see the separation of the heavier particles. Okay, so that's how we can separate the colloidal solutions. Definitely filtration would not it won't help here. That's how centrifugation is the method which is going to give the separation of colloidal solution. Is it clear, students? Make a note of this quickly. I hope you are able to consider this is nothing but what? Lighter particles. They are getting separated. Okay, same phenomena can be observed, or where is the application of the centrifugation? We can separate the blood. We know that blood is made up of RBCs, WBCs and what? Plasma. Plasma is lighter in weight. Okay, comparatively WBC and RBC. And we are going to take the blood sample in the test tube. Okay, we are going to put these test tubes in the machine, and with the rotation what we can do? We can do the separation of these three components of blood. Okay, and whoever needs it, if the person is like if he hasn't enough amount of plasma in its blood, we can directly transfer the suitable plasma from the suitable blood group, and only that component is going to get transferred. Okay, we don't have to transfer the complete blood. Only if suppose RBCs, then we can just shift, or we can transfer certain amount of RBCs in that person's blood. Okay, so that is what is the magic of the technology. All right, how it happens? It happens with the help of centrifugation technique. Okay, which works on the centrifugal force. Okay, got it? Let's move ahead. Colloidal solutions may be defined as, okay, so here is the proper definition of colloidal solutions. Solutions in which size of the particles lies in between those of the true solutions and suspensions are called as what? Colloidal solutions, or simply colloids. Okay, so we can refer this solution as what? Colloids. Due to relatively small size of particles, these mixtures appear to be homogeneous, but actually they are what? Heterogeneous. Okay, and that's why we see the separation of lighter components and heavier components, right? Since the colloidal solutions are heterogeneous in nature, therefore to distinguish them to form true solution, the term sol is used in place of solution. Okay, so we are going to refer colloids as sol. Okay, SOL, sol. So since the colloidal solutions are heterogeneous in nature, okay, therefore to distinguish them to form true solution. Okay, we know that students try to understand true solutions are homogeneous, like to our eyes, or in appearance wise they are homogeneous. Colloids are also homogeneous, but we know that in actual they are heterogeneous, and that's why we can refer colloids as sol also. Okay, SOL, that's the same different name for the same type of solution. Okay. The solute-like component which has been dispersed or distributed throughout in a solvent-like medium is called the dispersed phase or the discontinuous phase, while the solvent-like medium in which the dispersed phase has been arrived or dispersed is called what? Dispersion medium or the continuous phase. Do not get worried. Okay, so it looks very lengthy, so I'm just going to explain you. Students, we have seen that whenever we are having solutions can have 9 combinations, right? It can be solid in solid, liquid in solid, gas in solid. On the basis of this different combinations, we have studied about the types of solutions. Are you all able to remember them? Like we talked about binary solutions, right? So there are 9 combinations of it. Likewise, in colloidal solutions also we are having basically 8 combinations. Okay, so before knowing about this, try to understand, it's very important. We are having dispersed phase and dispersion or dispersed medium. Okay, I'll explain this. Suppose I'm having a colloidal solution. I'm taking one test tube. Okay, if suppose I'm taking water in large quantity, and to this I am adding some what? I am adding some oil. This is water. Okay, students, it is liquid in liquid kind of solution. It is liquid in liquid kind of solution. Definitely it is what? Heterogeneous kind of solution. Okay, students, I am referring oil as dispersed phase, and I am referring water as what? Dispersion medium. What does it mean? It means oil is a dispersed phase who got dispersed in the medium water. So what is the medium which we have taken? Water. So that is referring, like we are going to refer the medium, or the one which is in the larger quantity is your dispersion medium. Okay, into that if you are going to pour any other component which is lesser in quantity, that can be referred as what? Dispersed phase. Alright, so let's revise this again. The solute-like component. So definitely oil is in lesser quantity, and for us we know that like whatever if you are going to add in lesser quantity, that becomes your solute. So it's like solute. Okay, it's a solute-like component which has been dispersed. It has been dispersed or distributed throughout in a solvent like medium. Okay, oil is a solute like medium, it is been dispersed in a solvent like medium. So here we are having water which is nothing but solvent like medium called the dispersed phase. So this becomes your dispersed phase or discontinuous phase. Okay, while the solvent like medium in which the dispersed phase has been arrived or dispersed is called as dispersion medium. Try to understand, water becomes your dispersion medium, okay, and it's bigger in quantity. We are going to add some solute like substance which is your what? Dispersed phase. That's it. Do not get confused. Alright. Solute like substance is your dispersed phase. Solvent like substance is your dispersion medium. Got it? Any confusion? Because it's again very important. This is very important when we study about the colloids. It becomes very important to understand which is the dispersed phase or which is the dispersion medium. It's a medium, right? In this medium something is getting dissolved. Okay, in this medium something is getting dissolved. So this medium is dispersion medium, and into this one substance such as the phase of that substance is going to get what? Dissolved. That is dispersed phase. That's it. Got it? Let's move ahead. The heterogeneous system thus obtained is called colloidal system. Of course, whatever we are going to get after mixing dispersed phase in dispersed medium, we get colloidal system or the colloidal dispersion. Okay. So here colloidal solution contains two phases, students, broadly dispersion medium and dispersed phase. I am just going to write for your like the example which I have taken here. What was the medium? It was water. Dispersed medium was water. Phase which we have taken, that was oil. So let's talk about dispersion phase, medium. The component of colloid in which dispersed phase is present. Okay. So it's a water in which oil is present. So let's read it in like this. So it's a component or dispersion medium of colloid in which oil is present or dispersed phase is present. That's it. Moving ahead, we are having dispersed phase. The solute or dispersed particle in a colloid is considered as dispersed phase. Okay, so oil is dispersed phase which is dispersed in the dispersion medium. All right. So students, based on the state of dispersed phase and dispersion medium, colloids are of following type. Okay. So dispersed phase is liquid and medium is gas. That means liquid in gas. Okay. So that has a specific name. It is aerosol. It's very important. So make a note of this chart very quickly along with the examples. So fog, mist, clouds, these are colloids. They are aerosol. How? Liquids in gas phase or gas medium. Dispersion medium. Correct? Moving ahead, we are having solid into gas. We are having solid which is like solid as a dispersed phase is getting dispersed in dispersion medium which is gas. It is aerosol. Okay. Smoke dust, automobile exhaust, these are some examples. Moving ahead, we are having gas as a dispersion phase. I am going to write solute like substance, and here these are solvent like substance. So do not get confused, students. So gas in what? Liquid. Going to what is the name or type of this type of colloidal solution is known as foam. So definitely you have seen foams, whipped cream, shaving cream. These are the colloids which we use. But here gas is getting dissolved in liquid, and that's why it's a foam is getting generated. Alright. Fourth we have is what? Liquid in liquid. Liquid in liquid. Dispersed phase is getting dispersed in the dispersed medium, that is liquid. It has a specific name, students. It's emulsion. And again I am going to emphasize on emulsion because in the next class we are going to talk about emulsion in detail. So what are the examples? It's milk, cod liver oil, ice cream, face cream. These are few examples of emulsions. Moving ahead, fifth, solid in liquid. This is your, I am going to write DP and DM. Okay, for our convenience, DP and DM. Dispersed phase is solid and medium is what? Liquid. is what? Sol. Starch solution, protein salt, then we are having gold salt, arsenious sulfide salt, then we are having milk of magnesia and mud. These are few examples of what? Sol type of colloidal solutions. Okay. Quickly students, make a note of this. You can take screenshot of this. Next we are having this dP as what? Gas, and dm as what? Solid. So gas into what? Solid, giving you solid foam. So always try to remember the type of colloidal solution also. Example, foam rubber, sponge. Okay, these are some examples of what? Solid foam type of colloidal solution. Then next to that we are having liquid is getting what? Dispersed in solid. It's gel, student. So jelly, cheese, the butter which we eat, these are colloidals. But what kind of? They are gel kind of colloidals. Alright. Next to that we are having solid in what? Solid. Solid sol. Simply solid sol. Okay. Colored gemstones, rock, salt, milky glass. These are few examples of what? Solid sol. Okay, make a note of these examples, students. And yes, you are going to remember all of this. Yes, it's very, very important. 1, 2, 3, 4, 5, then 6, 7, 8. And we left with one combination, students, gas in gas. Actually, that looks like a homogeneous mixture, and that's why we haven't kept the combination here. That's why we are having 8 type of colloidal solutions. Got it? So here is the a diagram where we have shown the combination. So this is your dP, that means your solute like substance. Here is your dm, that is what I am just going to write, because there won't be any confusion for you all to understand it. Okay, so solid is the medium, liquid is the medium, gas is the medium. Okay, based on this, like this is the solid which is solute. Okay, so if I am going to take solid as a dispersion medium, solid in solid, so it is going to give you something like this. Okay, so that is what? Solid sol. Alright. Then we are having dispersion medium as what? Liquid, which is like green in color, and our solid, this is what? It is sol, students. Okay, quickly, it's a very, again it's a memory map. Okay, instead of remembering all the combination one by one, here on one single page you can remember each and every combination which we have studied in case of colloidal solution. Okay, next to that we are having gas as a dm or dispersion medium. Into that solid is what? Solute, or it's what? Dispersed phased. So it is dispersed, and that's why it's giving you solid aerosol. Okay, likewise we are having solid, can you all see? Solid as a dispersion medium. Into that liquid is getting dispersed, and the combination is what? Or the type of colloid is what? Gel. Likewise we are having liquid in liquid, it's emulsion. Alright. So next to that we are having gas, which is nothing but your dispersion medium, and into that we are having liquid. So this is nothing but liquid aerosol. Okay, I hope you all are able to follow this. You just have to read. This is solid. Okay, the blue colored one is what? Dispersion phase, and into that we have added gas. See, these are the gas particles. So it's a type of colloidal solution. What type it is? It's solid foam. Okay. Next to that we are having liquid as a dispersion medium. To this we have added gas as a dispersed phase, and that's why it becomes your foam type of colloidal solution. Next to that we are having gas as a dispersion medium, and we are using gas as what? Dispersed phased. Okay, so it looks like a homogeneous mixtures. Okay, so there are not known examples of this, but it comes under homogeneous kind of mixture, and that's why we are having 1, 2, 3, 4, 5, 6, 7, 8 kind of combinations of different phases and different medium basically. Alright. So that was all about it, students. Here we have covered the third type of solution, that is nothing but colloids. So like whatever the important points or the properties we were supposed to study, we have covered all of them. All you just have to do is revise this topic again and again. Okay. So we are going to meet in the next class. Till then, bye bye and take care.